Okay, so what I have here is a power supply connected to this long skinny wire. Now notice this wire, if you look over here, it runs back and forth 10 times. Okay, and so each length is a meter long, and these holes allow me to tap into it at different lengths. So if I connect right here, I remove 1, 2, 3, 4 1 meter lengths, and now I only have 1, 2, 3, 4, 5, 6 meters of wire. So notice the current changes when I do that. Now, as I get to shorter and shorter lengths of wire, the current will actually grow quite large. So I'm going to modify this circuit by adding a resistor in here, right here, and just so I can reach the other end of this cable. Oops. I'm going to use this. The breadboard is here just to hold this in place. And then I'll tell you at the end of the video, I think that's a 10.3 ohm resistor. I've got it written down. I'll tell you at the end. Okay. So now, right now we don't notice it affecting the current that much. Now this number is not very trustworthy. We only see 2 sig figs. I know I can get more with a DMM. And this one's only got 1, so this is not a very reliable meter. It gets you approximately right. But so let's take a DMM here, and let's measure the voltage of this. It should be less than 20, but more than 2. And so we get another sig fig there. That's a more reliable number. And likewise, I want to measure the voltage across this, so I'll bring in a second DMM. This should probably be less than 2. I don't know. We'll find out. Alright. So as we change to lower, we'll have to watch this and see if we go over limit, because when we get to very short lengths of wire, that may be an issue. So now what we can do is just change the length of wire and record these numbers. Hopefully this one, the voltage of the power supply, is not changing. And this one should change because we have the length of this wire changing. So let's see what happens. Okay, I'll shout it out. This is 10 meters. 9 meters. 8 meters. Looks like it's changing a little. 7. 6. 5. 4. Starting to get lost. 3. 2. Oh, we might go over limit. 1 meter of wire. Ooh, just squeaked in under 2. Alright, so that's cool. Notice what happened right here. Look at this current. If we hadn't put this little resistor in here, we'd be going crazy with the current right now. We're almost at 200 milliamps. So now I'm going to measure the size of this wire here, and if you can't read this, that's okay. So notice what I'm doing here. I'm measuring the size of the wire. I'm using the flat faces. And I've got it written down here as a backup if you can't see. So I found this information here. Again, this resistor was 10.3 ohms, and the size of this wire I found was 0.52 millimeters. Let's call that good.